So we've been working on this resistor in our previous videos. Now what I want you to do is pause the video and calculate the power that is being used by each resistor as well as the total power. Okay, you calculated it? Let's see the power used by each resistor. We want the power used by R1 equal the current through R1 is 0.261. Well, first of all, you know the formula for power. P equal IV, P equal I squared R, and P equal V squared over R. These are the three formulas, right? Now, remember, you have the three formulas here, but the fact is, if you start with P equal IV, and then you know that current is volt over resistance, you could use V over R and put here instead of I, and you have power is volt over resistance time, or I times, oh, you don't use the I, I'm mixing up myself. V of volt over resistance times volts. So the volts at the top multiplied to give a V squared over R, right? And then if you consider that V equal IR, you could say P equal IV, but V equal IR. So remove the V and put IR there instead. So P equal I times IR. But I times I is I squared. So P equal I squared R. Alright? So those are the three basic formulas for power. Anyway, let's use the P equal IV here. The current is 0.261 amp. So P equal I 0.261 amps times the voltage drop was what? 391.5 volts times 391.5 volts, and that gives you, let's see, calculator. So you have 0.261 times 391.5 equal 102 point, let's put them to one decimal place, 102.2. 102.2 watts. If you had used I squared R, what would happen? It would have been, here's my calculator. Now let's get back my calculator here and use I squared R. 0.261, that's the current, squared, multiplied by the resistance, 1500 equal 102.8, 102.2, I mean. Suppose you use V squared over R, what would happen? The V, what was the voltage again? My. Alright, so get back my calculator and use V squared over R for it. If you use 391.5 squared equal, and divide that by 1500 ohms equal, you get back your 102.2. So you could use any of the three formulas, alright? But we have a power usage of 102.2 watts. So 102.2 watts being used by R1. What about R2? power being used by R2 equal the same current 0.261 times R2 time, let's use voltage drop 182.7 equals, what do we get for our power? So 0.261 multiplied by 182.7 equals, we get 47.7 watts. 47.7 watts. Alright? 47.7 watts of power we use. Alright. That's the power. 47.7 watts. Now, what about the power being used by R3? So, power being used by R3 equals, could use IV to 0.086. So that's 0.086 multiplied by, what's the voltage drop across it? 25.8 volts. So 25.8 volts equal, we get back our calculator. We have here is 0.086 times 25.8 equals 2.2 watts. We have 2.2 watts being used by R3. I have 2.2 watts. What about R4 now? The power be used by R4 equals, we have a current of 0.172 amps. We have 0.172 amps multiplied by voltage drop of 25.8, same voltage, 25.8 volts equals alright, so that's 0.172 times 25.8 volts equal 4.4 watts. 4.4 watts of power being used by R4. So that's 4.4 watts. Let's add them all up and see what we get as the total power. We have 102.2 plus 47.7 plus 2.2 plus 4.4 equal 156.5 watts. So total power is 156.5 watts. Suppose we find the total power by multiplying total voltage by total current, applied voltage by total current. What would we get? Let's see. if we have 600 volts multiplied by 0.2, not 0.5, 0.261 amp peak IV equal 156 point, well, 6 just the same, 0.5, 0.6. Because of the running off, you don't get it directly. If you multiply current time, total current, time applied voltage, you get the same thing, 156.6 watts. Alright? Now notice that R4 is using twice the power of R3 because it has half the resistance. Being less resistant, it has higher current, so more power. Right? So those loads that have higher power, they have lower resistance. But anyway, that's it for our total, for our individual power being used by each resistor, as well as our total power being used by the circuit.